Hi, Lars. This is Ryan here. I'm excited to share with you my take-home assignment I've done yesterday and today. So I've made a simple algorithm for computing optical flow on the ESP32, and it does that after receiving a grayscale image from the host computer over UART, and then it converts the data from a 1D array back into a 2D array and saves them into these two 2D arrays. After that, it puts in the two image frames into the compute optical flow algorithm, which then does a simplified version of Lucas Canadi. So it calculates the matrix inverse, and if the determinant of the matrix is 0, meaning it's not invertible, it will just return UV vectors, the UV values being equal to 0. Yeah. So then after that, we'll scale up the UV values by a factor of 100 to keep up to 2 decimal points of precision, and then we'll send these back to the host computer using 2 bytes to represent each. So I'll be sending back a 16-bit signed integer. So then after that, so I've already flashed the code onto my ESP32 over here. So after that, we'll go into the main code. So in the main code, we'll call a preprocess video data function. So this will call my preprocess apply function. So here I'm using OpenCV to do video capture on a source video. So the video we're using right now is a POV video of a guy driving his dash cam. So it'll extract the 16 by 16 region of interest in the center of the video, and then change it into a grayscale image, as well as doing a Gaussian blur before sending it over. After that, after each frame is sent over, and the ESP32 has received 2 frames, it will send back the UV values, which will then be read by the host computer using this function. So it'll rescale back down the values, dividing it by 100, so I can get the 2 decimal point precision, and then I'll add it back to the flow vector table. And this will keep on continuing until I've reached the number of data counts I specified. So then if we go back to the main function, under preprocessed video data, it will also call it the OpenCV version, so I can have a comparison to validate against. So using OpenCV, I'll be using the far and back algorithm to calculate the optical vectors in the 16 by 16 grid in the same spot in the video, and then I'll extract the optical vector at 0.88 in the video. So after that, I'll also attach a square in the middle to represent the optical vectors at each frame in the video, which you'll be seeing shortly over here. So let me just run my main function. So right now it's sending all the serial data over, and the ESP32 is sending back all the UV values, and shortly you'll see a preview of the OpenCV running the optical flow algorithm. So you can see that the direction is being represented by the hue, then the magnitude of the vectors are being represented by the value, so how bright the hue is. So in this video, the main goal is to make sure that the directions that is registered by my ESP32 is correctly in line with the directions of the optical vectors of the OpenCV version. So this video should end in about a few more frames. So after that, it generates a graph. So here, we'll first get a comparison of the magnitudes of the vectors. So you can see that the rises in the magnitude are about in line with that of the OpenCV model, but it's not that good because of the noise. But then you can see here that the angles recorded by my ESP32 model is pretty in sync with the angles generated by the flow vectors, using the OpenCV model. So now we can try a video also of a traffic cam. So over here, I'll put test.mp4. Then I'll restart my ESP32, and then I'll send it over. So in this video, it's another test, and so the region of interest will be in the middle, and it will correctly detect using a magnitude spikes of when the car passes through the center. Oh, I didn't save it. Save it. So over here, you can see the car is going through the middle. Yep, so here is the video using the OpenCV model. So you can see every time a car passes through, it changes from black to a different hue, representing each time a car passes through. So here the goal is to see if the ESP32 is able to correctly line up the magnitude spikes cleanly with the same time that the OpenCV model has a magnitude spike in the optical vectors. So the video will end about shortly when this car approaches. Yep, so that's the whole video, and you can see the spikes and optical flow vectors, like each time the vehicle passes through the center of the screen, is in line at the same time with the vectors that are calculated by my ESP32 pretty closely. Over here, you can see the angles is not that great because of the noise and the nature of the video. So, and then if you like, you can see on my GitHub repo, I wrote a bunch of my write-ups about this. and you can see my results that I've just showed you earlier on the different videos and how they fare. Okay, that's all I have to share about my take-home assignment. I'm hoping to hear from you soon. Looking forward to chatting with you about this. Thank you.